Welcome to Afghan Civil Engineer YouTube channel. Today we have come with the new topic, workability of concrete. So do not forget subscribe the channel, like the video and share with your friend. Today topic is very important and also it is very interesting topic for all civil engineer those they are working in the field, and maybe most of the civil engineer has faced this question in interview. So what is workability of concrete? Describing how easily freshly mixed concrete can be mixed, placed, consolidated and finished with the minimal loss of homogeneity. So workability of concrete, it is nothing but how much the concrete is workable, how easily we can mix the concrete, we can place the concrete, as well we can consolidate the concrete without losing of homogeneity. So it is nothing but it shows us how much our concrete is workable. So here are some of the factors which is affecting the workability of concrete. First one is mix proportions. It is also known as aggregate cement ratio. The higher aggregate cement ratio, linear is the concrete. So here it explains that whenever our aggregate and cement ratio is higher, it is higher, then linear is the concrete. So our concrete will become weak, which offer less workability. So whenever we are increasing the aggregate cement ratio, it means that we are increasing aggregate. Here we have given one example. In this one the aggregate is less, so we have less surface area, and in this one we have more aggregate. So whenever we have more aggregate, then our surface area will be also more. Whenever our surface area is more, then we need for more cement and water paste to lubricate the aggregate. So whenever we increase the aggregate cement ratio, our workability will be decreased. Because of that, our surface area is increasing. Whenever we are decreasing aggregate and cement ratio, then our workability will increase. Now we are coming to water cement ratio. Workability increase with the increase of water content. It is very simple. Whenever we are increasing water content, then workability will increase. If the water cement ratio is small, it indicate high amount of the cement. Whenever water cement ratio is small, it means that water is less and cement is more, which it indicate high amount of the cement, which is helpful for good strength. Whenever the cement is more, then the strength of the concrete will be good, but it will cause low workability. Whenever the water is less, then it causes low workability. Hence the optimum water cement ratio has to be maintained to balance the workability and strength of the concrete. So the last sentence says, it is very important. It says that we have to take optimum water cement ratio, because of that, whenever we want to maintain to balance the workability and as well as the strength, so for that purpose our workability, our cement and water ratio has to be optimum, because workability and as well as strength is very important for us in the concrete. So we have to take optimum water cement ratio. The bigger the size of the aggregate, lesser is the surface area, and hence the water cement paste will be required less compared to the small size of the aggregate. Now here we are coming to the example. Suppose whenever we have a large particle of the aggregate, then our surface of area is less. In that case, the workability will be more, because the same amount of the cement and water we are putting, so it need for less water and cement paste. Whenever we have large number of the aggregate, then in that case the surface area is more, and the workability will decrease, because we need for more cement and water paste, but we have less. That's why our workability will decrease. Now we are coming to shape of aggregate. Angular, elongated or flaky particle makes the concrete very harsh compared to the rounded aggregate or cubical shape of the aggregate. Here also the concept is same. Whenever we have the rounded shape aggregate, the surface area of the rounded shape is small, so that's why the workability will increase. Whenever we have angular, elongated or flaky aggregate, then in that case our surface area is more, so the workability will decrease. Now we are explaining surface texture. It is also the same as we explained before. Smooth texture aggregate leads to higher workable concrete in comparison to rough texture aggregate, as lesser is the area to be lubricated in this case. So whenever we have rough texture of the aggregate, then the surface area is more. Whenever the surface area is more, then our workability will decrease because it's need more cement water paste to lubricate. But the smooth aggregate, the surface area is less and the workability will increase because it will be lubricated very easily. Now we are coming to grading of concrete. The well graded aggregate, as we know that whenever we have the concrete of well graded, there is big particle and there is small particle. The void between the big particle, it will be filled with the small particle, and the void between the small particle of the aggregate, it will be filled with the cement water paste. So whenever the void is less, and then the workability will be increased. When there is poorly graded aggregate, then on that case our void is increasing. Whenever the void is increasing, the workability will decrease because we need for more water cement paste to fill the void. Admixture. There are many admixture can improve the workability. Most of the admixture are improving the workability. Now we are coming to the time factor. Fresh concrete stiffen with the time and lose workability. After mixing up the concrete, some water is absorbed by the aggregate and some may be lost by evaporation and some may be spent by initial chemical reaction. So it says that with the time the workability of the concrete is decreasing because some of the water will be absorbed by aggregate and some of the water maybe it will be evaporated, and also some of the water maybe it will be used by the chemical reaction. So that's why with the time the workability is decreasing. Now we are coming to the last factor, that is temperature. High temperature reduce the workability and increase the slump losses. Whenever our temperature is high, so there is more possibility of evaporation of the water from the concrete. So it also decreases the workability. So be with us in the next video. We are going to explain all those tests which are going to be conducted in the field for the finding of workability. So subscribe the channel if you like our video, then share with your friend.